In today's lesson, we're going to have a look at finding the surface area of some prisms. Last lesson, we introduced the definition of surface area. We said that the surface area is the total area of all of the faces of a 3D shape. As before, recognising the properties of 3D shapes is really going to help us, knowing the number of faces that we need to calculate, as well as thinking about the nets of a shape. In this first example, we have a trapezium-faced prism. I can see that it has 6 faces in total. That means there's 6 areas that I need to work out. So let's start by thinking about the face at the front, this one just here. It's a trapezium, and I know to work out the area of that, I need to add the parallel sides together. That's 8 add 12, divide by 2, and then times by the height, which is 7. 8 add 12 is 20, divided by 2 is 10, times by 7 gives me an area of 70 centimeters squared for that front face. I know that the face which is hidden at the back is also going to be the same area because that's also going to be a trapezium. So my face 2, I can say, is also 70 centimeters squared. My third face is going to be the one on this right hand side just here. I know that that's a rectangle, and the area of that rectangle is 8 by 9. So 8 times 9 gives me an area of 72 centimeters squared. Now I need to be careful when I consider this left hand face just here. In this particular example, it's going to be the same as the area I've just worked out. So I can say that my fourth face is also 72 centimeters squared. This is only true because my trapezium face at the front is isosceles, which means both of the diagonal edges are 9. If the trapezium wasn't isosceles, I'd have to look at what the diagonal length was and times it by the depth, which would give a different area. I can work out my fifth area, which could be this area on the top just here, as it's 8 centimeters by 8 centimeters, again another rectangle. So I can say 8 times by 8 gives me an area of 64 centimeters squared. And lastly, I have the area which is hidden at the very bottom. Again, that is a rectangle. It's 12 centimeters by 8 centimeters, and that gives me an area of 96 centimeters squared. The last thing that I need to do is work out the total surface area, so that's adding all of the areas for each individual face together. I can use my calculator to help me do this. So I have 70 plus another 70 plus 72 plus another 72 plus 64 plus 96, which gives me a total area of 444. Now I need to make sure I write all of this down as working out, so I can say that my surface area was equal to 70 plus 70 plus 72 plus 72 plus 64 plus 96, and that gave me a total surface area of 444 centimeters squared. That's our final answer. Just remember that our units are going to be centimeters squared because we're talking about an area, not a volume. In this second example, I'm asked to work out the surface area of a cylinder. I'm going to use the net of this shape to help me answer this question. The net would look a little bit like this. Now I can work out both of the circular faces because I know each of them are going to be the same, and they're going to be given by pi times the radius squared. The rectangular face, however, is going to be a little bit more difficult to calculate. Although we're given the height of it, we don't know the distance going across. This distance is going to be equal to the circumference of our circle because we want that rectangular face to wrap all the way around the outside of the circle. So I can say that this length just here I can work out by doing pi times diameter. That's because pi times diameter gives us the circumference of our circle. So I know that my first face, the circular one, is pi times radius squared. I know that my radius is 7, so that's going to be 7 times 7, which is 49 times by pi. I'm going to leave my answer in terms of pi for now. I can also say that my second area, which is this circular face at the bottom, is going to have the same area, so that's 49 pi as well. As I've said already, the third and final face, this rectangular one just here, is going to be a little bit more tricky to work out. First of all, if I know that the radius of my circle is 7, I know that the diameter is going to be double that length, which is 14. So I can work out the circumference and this length of my rectangle using that. Pi times diameter would mean 14 times by pi, which is 14 pi. And I then need to times this by the height of my cylinder, which is the height of my rectangle, which is 15. This gives me a final answer of 210 lots of pi. I can use my calculator to help me work that out if I need to. So the last thing that I need to do is add up the area of all of my faces, and again I can use my calculator to help me do this and round my answer to 1 decimal place. Our first face was 49 pi, add another 49 pi, that's going to be our second circular face, plus the rectangular face, which was 210 pi. That gives us a total area of 308 pi. I can convert that to a decimal, and that means that my total surface area is 967.6 centimeters squared. The last thing that I need to do is write all of this information down as working out. I know that my surface area was 49 pi plus another 49 pi plus 210 pi, and in total that was 308 lots of pi, and when I put that in my calculator and rounded to 1 decimal place I got 967.6, and again my units are centimeters squared because we're looking at a surface area and not a volume. So that is my final answer. Now your first task for today is to find the surface area of the 9 shapes that are on the screen right now. If you prefer to have a worksheet in front of you, this is attached to Show My Homework in the Resources to Help You section. Questions 2, 4 and 6 are all cuboids, so you can think about what we did last lesson to help you get the answers a little bit quicker. For the others, you need to think carefully about the areas of each individual face. You've got triangles, parallelograms, trapeziums and circles that you need to work out the areas of. Once you've completed all of these questions, you can check your answers against the solutions that I've posted onto Show My Homework. If you have made any mistakes, please try and correct them before moving on. When you have done all of it and you are happy with your work, you can take a photo of it and upload it to Show My Homework so I can see how you've got on. For those of you who want a bit of a challenge, you can pause the video here and have a go at working out the surface area of both of these shapes. These are much harder than any shapes you'll have to work out the surface area for, but it's good practice nonetheless. If you do decide to challenge yourself, it's important to recognise that any hidden areas would not be included in your calculation. For instance, in the first example, the rectangular face that's hidden between where the 2 cuboids join would not be included as part of the surface area. So if you do want to challenge yourself, pause the video now and the answers will come next. Here are the answers. If any of you have managed to get either of those 2 answers, a massive well done because they're really difficult. So your last task for today, which I'd like everyone to do, is to log into MyMaths and complete the nets surface area task that I've set for you. As always, the initial school login is Uppingham and Acute, and your portal logins are attached to Show My Homework in case you've forgotten them. You should aim to get at least 70% on this task, so please retry it until you get that score. If you've done it already and the task has disappeared from your list but you want to retry it, you can find it again using the Results tab once you're logged in on the left hand side. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.